Testing 1, 2, 3. Okay, so let's take a look at the back side here. So now we have a very interesting looking graph, as it says there. It looks kind of complicated, but it's not that bad. So let's look at our first one. It says the limit as x approaches infinity, f of x approaches what? So let's take a look at this. As x approaches infinity, f of x approaches, looks like it's going to keep going this way. So looks like we've got an asymptote here. So let's say that's 1, 2, 3. It's at 3. So the limit as x approaches infinity, f of x approaches 3. Now the next one says the limit as x approaches negative infinity, f of x approaches negative infinity, as it's going to keep going down. Looking at our next one, it says the limit as x approaches negative 4 from the right side. So where is negative 4? Let's see. So we have 1, 2, 3, 4. That's negative 4. So as x approaches negative 4 from the right side, f of x approaches 4, 5, 6. Looks like 6 right there. And our next one says the limit as x approaches negative 4 from the left side is, again, 6. So the limit as x approaches negative 4, f of x approaches 6 because the left hand and right hand limit are the same. So now we look at f of negative 4. So when x is negative 4, f of x is 6. So this is 6. Okay, so let's look at our next one. The limit as x approaches negative 1 from the right side, f of x approaches what? So where's negative 1? Here's negative 1 right here. So as x approaches negative 1 from the right side, which means it's going to be this part of our graph, then f of x approaches, this is negative 1, negative 2, negative 3, negative 4, negative 5. So as x approaches negative 1 from the right side, f of x approaches negative 5. Now the limit as x approaches negative 1 from the left side, f of x approaches, let's use a different color. So here's negative 1 again. So as x approaches negative 1 from the left side, we get 1. Right? Our point right here is 1. So the limit as x approaches negative 1, f of x approaches what? Nothing. It approaches nothing. It does not exist because our left hand limit and our right hand limit are not the same. Sorry, this is right, this is left. They are not the same. Therefore, the limit at this value does not exist. If you remember back in possibly algebra, I think, or pre-algebra maybe, you had an input-output chart, and you can never have one x go to the same y, right? This is not possible. So, just like that, you cannot have the same x go to different y's. So, the limit at that value does not exist. So, f of negative 1, however, it looks like we have two values, right? There's one right here and there's one right here, but which one is f at negative 1? So f at negative 1, when x is negative 1, f of x is actually 1. We're going to use this value because this hole, when it's black, when it's filled in, that means that it's included. Whereas this one here means that it's not included. Think about like a number line, right? When we used to talk about including and not included, this meant that it was not included, that 1 is not included. This one meant that it was included, right? So f of negative 1 is 1. So let's take a look at our next one. The limit as x approaches 4 from the right side, f of x approaches what? So let's look at where 4 is. So 4 is 1, 2, 3, 4 right here. So as f of x approaches 4 from the right side, f of x is equal to 7, 8. Looks like it's 8. And as f of x approaches 4 from the left side, which means right here, f of x approaches negative 5. So again, because our left-hand limit and our right-hand limit are not the same, the limit as x approaches 4, f of x does not exist. It does not exist. The limit does not exist. So f of 4, again, we look at the one with the closed circle because that means it's included. So f of 4 is negative 5. Now the next question asks us to find x when f of x is equal to 4, which means that so that our graph is going to be, our coordinate, is going to be some x when y is 4. So when f of x is 4, what is x? So let's look at our graph. So when y is 4, so let's take a look at this. When y is 4, f of x is what? Oh, I'm sorry. Okay, so let me go back to this. Okay. So our next question asks, find x when f of x is equal to 4, which means that our coordinate will look like some x when y is 4. So when f of x is 4, what's our x? So let's look at when our y is 4. So that's this part right here. What are our x values? So let's take a look at that. So we can kind of estimate these. So I'm going to actually erase that and this so that we can see a little bit better. So at 4, it looks like right about here, which is about little after 2. So let's just say that's about negative 2.3. So one of our values will be negative 2.3. Let's go back up to our graph. It looks like we have another one right here, which is about, so this is 1, 2, 3, 4, 5, 6. Somewhere in between 5 and 6. Let's call that about negative 5.4. And we have one more on our right side here, which is about 1, 2, 3, 4, 5, 6. So it's a little bit before 6, so let's call that about 5.8. And this is when, these are all the x's when our f of x is equal to 4.